There you go.
So actually the co-host is not necessary, but allow to record is what you needed. Okay.
Yep, got it.
All right, excellent. Okay, today we are going to talk about DNS, domain name system. This is a critical piece of networking technology that is fundamental to pretty much everything we do. Knowing DNS is important regardless of if you're a network engineer or a software developer. You need to understand how name resolution works. And so we're going to walk through the steps of name resolution, how it works for a common scenario like going to a website, okay, and therefore we can ask questions and we can walk through this and figure it out and help you all to understand what goes into a DNS resolution, okay? So I want to, let's see, okay, let's put this here, create now. So this was an older one I was looking at, but I want to kind of just start, I want to just start from scratch. And I want to now share my screen. Okay, let me share my screen with you all. I can just share the whiteboard, I guess. Let's see how this does. Okay, everybody can see my whiteboard now?
Yep.
Yep.
Okay. All right. So, all right, so here is what we've got with DNS, okay? And one of the keys with DNS is a DNS recursive search. Okay, so DNS, domain name system, is the way to resolve a name to an IP address. So if you're over here on your laptop, okay, and you want to go to www.amazon.com, okay, with your laptop. Okay, when you type in www.amazon.com in your browser, it cannot just go directly to Amazon.com. It has to know the IP address. That's how computers work, is it ultimately has to have the IP so that it can create the route with layer 3 from your laptop to Amazon, to the website, and okay, so it has to have the IP address, and if you don't have the IP address, that's what DNS does. It resolves this name, www.amazon.com, to an IP address. It's like your home address. Okay, your IP address, of course, is like your social security number, your home address. It's assigned to you specifically. It's unique, and layer 3 can create the route, and layer 4 can create the data in packets and send it, and they can put in layer 4. You put in the specific port, and for DNS, the port is 53. Okay, so we'll talk about that more in a minute, what that means. But let's say you're going to Amazon.com. So you have what's called a resolver cache, and Peter, you can just throw in, you can just jump in at any point when you want to add stuff to this. Okay, you have a resolver cache. It's a memory location in your PC in memory that has all of the sites that you have gone to and locations. And if you've gone to those, it keeps those in a cache. Now, this cache is not just once it's in there, it's always in there. It has a time to live. And it's a certain time in seconds, time to life, time to live. Time to live, called TTL, okay? Now, time to live is in seconds, and it says this is, you've gone to Amazon.com, and I'm in your cache for a specific period of time, and once it counts down those seconds, it's out. So let's say you're going to Amazon, but you have not gone there since you're powering on your laptop. You get your IP address with Dynamic Host Control Protocol, and you type in, you go to your browser, you type in www.amazon.com, okay? Well, first it looks in your resolver cache. There's no Amazon.com with the associated IP address. So now it goes to your DNS server, okay? Your DNS server, if you're on campus, is up in O'Grady Library. You have a DNS server service. It may be on a server with other things. Peter, is this integrated into Active Directory right here?
Correct. Every domain controller is a DNS server.
Okay, so here is your Active Directory DNS server, and the IP address that you have received from DHCP gave you this DNS server address. So you make the request, hey, do you have www.amazon.com? And it is not the owner of that address, so it looks in its own, it has its own resolver cache, okay? This cache says, no, I don't have, well, we're gonna make the assumption it does not have Amazon.com, okay? And then we'll talk about the scenario when it does have it. So it does not have it, or it's aged out, and it has the same time to live, a certain time in its cache as well. So then there is a portion, okay, of this DNS server that is the resolver. And the resolver says, DNS passes it off to the resolver and says, hey, go get the IP address for Amazon.com. So what it does is it goes out to the internet, okay? This is the first iteration of a recursive search. And it goes to the root NS server or name server, okay? So here's your root server right here, okay? Here's your root server. And so here's my, this is my little icon for a server. Back in the day, this is more like a workstation with a CD drive up here. That's the longer dash. And this is a little 3.5 floppy disk drive. Because that's how they used to have little icons, right? But of course, we don't use 3.5 floppy disks, and we don't even have CD-ROMs for the most part anymore. But anyway, that's my little, looks like a workstation, but that's my server, okay? So here's my server here. And the root NS, the root name server, the first iteration goes to there. And the root says, where are you going? And if you go back to the name over here, what it does is it looks at this name from right to left. It says, oh, the address is www.amazon.com. So what it does is in this root server, it has a list. Sorry, I need to go back to blue here, or maybe green. Okay, it has a list, okay, of all the .com top-level domain servers, edu, military, gov, what am I missing? Net, what, org, everything. What else you got?
.tv.
Something that has US or something else, EU, I don't know, there's some other weird ones. So what it has is a list of the top level domain servers. So top level domain servers, which have a list of all of the name servers for all locations for com, edu, whatever. So it gives you back an IP address to go to the IP address for a top-level domain server. So then you go to your top-level domain server, and in this case, it's a top-level domain server, a .com top-level domain. Okay, it goes there, and it says now, I'll go in red. It says, okay, I'm looking for Amazon.com. So it says, okay, Amazon.com, it's going to give me back the name, not the name of the website yet, not yet. It's going to give me back the name of the name server. Okay, it's really going to be the name server or the domain name server of Amazon.com. So what we've got is this server. So we have some other acronyms. This is the Start of Authority, SOA. My DNS server, or really Peter's DNS server at St. Martin's, is the start of authority for all IP addresses associated with St. Martin's. So what it has is this top-level domain server has all of the name servers for any site that ends in .com. So it's given me the name server. So now I come down here and I go to, in this case, my square is not good. So here's my start of authority, which is the name server, Amazon.com. So it's giving me the DNS server, not the web server yet. So it gives me that. Okay, am I a perfectionist? I'm not sure, but I just like a semi-straight line. Okay, it gives me then this name server. So now I go to the name server. Here's my third iteration. I went with this resolver, I went to the root name server to get the a .com top-level domain. Then I went to the top-level domain. That gave me the name server for Amazon. Okay, and now I'm going to the name server at Amazon, and in a DNS server, it has a forward and a reverse lookup file. And these are just text files, okay? And these are forward and reverse, what they call zones, zone files, okay? And it says, it's asking now for the www. So I've gone now to Amazon. At their site, that is the start of authority. It's the owner of all IP addresses related to Amazon. And now it's saying, oh, you want the web server, www.amazon.com. So in its list, which is just a text file, okay, when it's not integrated with Active Directory, it's just a text file that has www.amazon.com, and then it has 52.13.1.7 or whatever, okay? It's just a text file with the name and the IP address. But do you think there's just one Amazon.com web server? How many web servers do you think Amazon has?
A lot.
They have thousands of servers, okay? Each probably behind a load balancer to pool them and provide, distribute the load. But these are not just in Seattle. These web servers are all over the world. They're in Europe, they're in Africa, they're in US, there's North America, they're in South America, okay? So when when you're asking for, I want the IP address of www.amazon.com, for us in Lacey, Washington, we are saying, what we're really saying is, we want the closest web server because that's going to have the least amount of latency, the least amount of delay to go to that website. It's going to give us the best experience on their website. So the closer you are, the better experience, the less of a lag or delay or latency is involved in the packets getting to the website and coming back and delivering that web page to our browser. So this DNS server actually does a quick lookup. Have you done an IP lookup? It says with an IP address, it says where does this reside from? Have you ever done an IP lookup like that? No? Okay. If you do an IP lookup, okay.
Yeah, we can't see your screen.
Oh yeah. You know, I only shared. Let me share my whole screen. Screen 2. Share. Okay. When I do a lookup, okay. You can do a lookup and you can put in your IP address. Okay. You can also find out what your IP address is, your public one if you're behind a network address translation, right? And my IP is going to pull out my actual. Okay, so here's my IP address right here. So if I do an IP lookup, oh, it's already shown right there. I'll put it in. Control V. I dump it in. No, maybe didn't copy it. Well, if I click up my IP, it's going to pull it up. I'll go back to that page. And where does it say it is? The ISP is Wave Broadband. They provided me the IP address. And city is Walnut Creek. So that's where I'm coming to you from today. I'm down in California. And here's my IP address. And it's from Walnut Creek. Okay. So DNS can do the same thing and go, where are you coming from? Oh, you're from Lacey, Washington? Okay. I'm going to give you the closest website for Amazon to your location so that you have the fastest and best performance. And so it gives that, it finds out where you're coming from, gives you back specifically that. And so finally, I get back the IP address here. I finally get back my, whatever it is, 52.13.1.7, okay, whatever it is. Okay, now, when it gets this IP address back in DNS here, it's going to put this IP address in the resolver cache. It's going to cache it, okay? And then it's going to give it back to me. Okay, it's finally going to give back 52.13.1.7. And I'm going to store that in my resolver cache. And it's going to stay in my resolver cache. So if I go to here, and there's if I go to command prompt, cmd. All right, let me close a few things because there's a big delay here. All right. So now, all right. So now let me drag it up here. So here I am And I'm going to do, this is probably too small to see, right? Let me zoom it up a little bit on the screen. Okay, give it a minute. And now this is going to zoom up here. It's not just as fast as it desperately can. There we go. Go up here to this. Okay. And I do DNS lookup. Amazon. Okay, here is Amazon. Okay, it's going to give me, here's the address right here. Cloudfront.net provided me that IP address. 65.8.171.9. Okay, and so it's going to give me that back, and it's going to put that in to my resolver. And now that I have the IP address, okay, I can go now to the actual website. So finally, I can actually go to, Amazon.com, which is the website, because there's more to Amazon than just their website. But here I can go to their website with the IP address. I can make the connection with the IP address with a TCP three-way handshake. We'll talk about that as well in future class, but makes a connection. I do a HTTP GET, which is the request to pull the pages, HTML pages from Amazon, pull them down and present them on my screen. Okay, so all of these over here on the right, the iteration to go up to the root NS was one iteration. The second iteration was go to the top level domain. The third iteration was go to the name server at Amazon. So it would give me, because it's the authority server for all things Amazon, and it would look up on its forward zone file, give me the IP address that's closest to my location for the web server, send it back to my DNS server, the resolver would cache it, send it to me in my laptop, and then it would add it to my cache, then I would actually be able to go to the website and pull it up. So here is this big, maybe a little convoluted looks like, but this is how this happens all the time. You're like, wow, that's a lot of steps. But remember, this all happens like a split second. All of this happens super fast, behind the scenes, in a distributed fashion, because if the root server is down, it'll go to another root server. If the top level domain server is down, in fact, the root will give it multiple COM servers to go to, and it'll try the first on the list, and it'll try the second one. So, so there's these COM servers and root servers and so forth are distributed around the world. And DNS is a distributed solution for name resolution, and works in such a way that they all have a certain update where they sync, and information gets into these COM servers and gets distributed amongst the different COM top-level domain servers. If you got a new website that comes up, the root NS, if you got other top-level domain servers that come up, those are added to the root servers and distributed amongst them. And then also if some new server comes up at Microsoft or Amazon, then that's added to DNS as well, and can be an option to be provided to somebody to go to when they do a DNS recursive search or do a lookup. And so this is how we get to any resource on the internet. It has to resolve to the IP address. All right, it's just.
What if you just enter the IP address directly?
Okay, yes. If you knew the IP address, you could enter it directly, and you wouldn't need DNS. But then you would have to have all these lists of IP addresses. It's a lot simpler for humans to remember a name. Go to Amazon.com or go to Microsoft.
I was just correcting you because you said this is how we go everywhere. I'm like, technically not.
Yeah. Oh, I see what you're saying. Yes, that's true. You're right. And if you had the IP address, you could go anywhere. If you're going to a specific server, whether it's a gaming server, a file transfer like FTP server, an email server, they all have IP addresses, but they also have names that can be resolved using DNS.
Mark, can I ask you, in looking at the diagram, I'd like to slow down and make sure that I understand your usage of the word iteration versus recursive. I noted that with the iterations, obviously, if you're making a request that's having to, for lack of a better term, ping off a number of servers, you're reiterating your request for information, but the recursive ones respond, I suppose, with like an answer to the query of what it is, and may actually send back data. So a recursive chain of events, of course, is trying to make sure that you get the right IP and then start that transport again the other way. Am I missing something about the differences between iterative and recursive?
Well, when you do a recursive lookup, you're doing multiple levels. So you're going from .com to .amazon to .www, and each time you go to a level, you are iterating in that level.
Yeah.
You know what I'm saying?
Right.
Okay, so recursion might refer to the step down process, where iteration is simply the physics of bouncing that off those sites.
Yes.
Right.
So
Okay.
recursion is one element of, iteration is one element of recursion.
Okay, and see, now that makes sense. That makes sense. And as you say, that each time it reaches a level of where the start of authority exists, at some point it's going to get an answer that allows it then to actually forward you through the network even further.
Yeah.
Yep.
So if you look at definition 3, it says a computer programming technique involving the use of a procedure, subroutine, function, or algorithm that calls itself one or more times until a specific or specified condition is met, at which time the rest of the repetition is processed from the last one called to the first. So yes, each iteration is a sub-element of this DNS recursive search. It's doing one iteration to the root, one iteration to the top level domain, one iteration to then down to the name server at Amazon. And then finally, it gets the answer. So all these steps were necessary to finally get the final answer.
Thank you for slowing that down, because now it makes perfect sense, especially in relation to us taking any of our C++ or C# classes. That difference about calling a function and it being a recursive, versus the iterations to carry out that makes absolutely perfect sense. So
cool.
Good.
Yeah.
And when you run your own DNS server, it will have a list of IP addresses that you are in control of, such as www.stmartin.edu or nac.stmartin.edu. Basically anything that you are in charge of. And then you also have set up in there, going to a root NS,
Okay.
Yeah. Yeah, exactly. So each of these DNS servers, like Peter said, is the owner of the IP addresses that it controls. And it then would be authoritative in giving you the IP number for the name that you're looking up. And just like all things Amazon, it has its own set of DNS servers or name servers at Amazon that owns basically doing that resolution from name to IP address. And the reverse of that is IP address to name. And without DNS, you're right, you would, for at least, if we're talking about just a website, for all the different websites you go to, you would need the IP address of every one of those sites in a list or something to go to. Instead, you can just type the name in and it will resolve it for you. It will find that IP address for you. You don't have to. So that simplifies access to the internet. Back in the day, you just had a big old long list of all these websites. They kept these lists in text files of places to go on the internet. Well, now you've got Google and you can do a search for, hey, I want to go to a site, a gaming site. I want to go to some type of software, free, open source software project, and you can start typing in keywords, you can find it, and it will give you a list of those. And then when you click on those names, DNS will go and resolve it. If it's not already resolved, it'll go and resolve it for you and give you the IP address so that you can actually access that site. So DNS, this is just an example of a website, okay? So, and there's other elements of DNS that it resolves for other things. One is that DNS resolves to find your mail server. DNS resolves to find your domain server with Active Directory, in fact, even. They don't have to be integrated, but they can be integrated, and that makes it simpler. And integrates these text files into the Active Directory domain database. The ntds.dit file is the database for Active Directory. So how it works is that you want to log into stmartin.edu, and you want to log into your account, or you're on campus and you're in a lab and you log in. You put in your stmartin username and your password and you log in. Well, how do you log in? Well, you have to reach a domain server, an Active Directory domain server. And how do you find that? Well, DNS comes into play because it goes to DNS and says, where is this server located? And it needs to take the name that you type in as your domain, and it needs to resolve it to an IP address. Now, when Peter talks about they're integrated, Microsoft has the ability to integrate its DNS with its Active Directory into the database, an encrypted database, so it's more secure, and it's also distributed and between different domain controllers on the same cycle as all other objects are in the Microsoft Active Directory domain. But it can be separate too, and in fact, DNS is the mechanism for resolving anything that we need an IP address to a name. So I want to open up a slide deck. And show you that there's several files that are used for DNS. This is the recursive search I was talking to you about. But let me expand it so you can see it better. Okay. So this is maybe a not so chicken scratch way of talking about the recursive search to a root server, .com server, and then DNS server, those 3 iterations, okay, to get back the IP address of where you're going. In this case, this is Microsoft, so they're going to Microsoft.com, all right? But the files, if you go to, let's go here. Okay, let's go to, okay, 26. Okay, these are the files that are in a DNS server. So if you install DNS on Linux or if you install DNS on Windows, you go, if it's Windows, I'm more familiar with that, you just go in and go into Server Manager and install DNS, and it goes to a wizard and puts everything on and starts the service, and then it's listening on port 53 for any type of DNS request. So the packet comes into the server and it has port 53. Oh, well, that's DNS traffic. So then it's sent to the DNS service to be looked at and to be taken care of. And then it says, oh, you want the IP address for Amazon.com? And then it goes into its recursive search to find that for you. Well, there's a bunch of text files. DNS really is just it's like a text-based database or spreadsheet. It's just text files with information. And you have, these are the different files. You have an SOA, you have an A record. This is the IP for host address resource record, and it's just a 2-column text file that says the name and the IP address. So if it's www.amazon.com, and then you tab over, and there is, or space over, and then you've got the IP address, or multiple IP addresses, right? And then you've got, there's a alias resource record, CNAME. MX is a mail exchange resource record. So whatever mail server that you have, if you need to find that so you can get to your email, it provides that to resolve to the actual IP address of the mail server. A service locator or SRV file, text file, has your Active Directory in it. It actually has the fully qualified domain name of the DNS name of the Active Directory server, which in the case of integrated DNS and Active Directory, it's the same IP address, of course, but it can be different. It can be on different servers. And so it has the name and the full name and the IP address so that you can find your Active Directory. And when you log in, it allows you to connect and log in. NS, the name server, resource record. And then this quad A, they call it a quad A, or there's 4 A's together, they call it a quad A record, is an IP version 6 host address resource record with names and again IP address, but not in the format of an IP version 4, but in the format of IP version 6. And then pointer is a reverse lookup file that just has IP address first, and then the second column is name. So it looks things up from the IP and gives you the name. Okay. Okay, so
Mark, if I can just lock that into my brain here. In the previous example where you showed the servers, A for address would be the A record, and of course your NS records are going to be the triple Ws. So in the case where you know your direct IP and type it in, it doesn't have to bounce back through that sequence. It literally can just jump right to the server 3 or 4 at that point because we've already got an IP match, so to speak.
well, you said in our example, we wanted to go to a website.
Right.
So the request comes into the DNS server, port 53, UDP, and it comes in and it says, hey, what's I need a name resolve, or really an IP resolve for the name www.amazon.com. And so the DNS server is gonna look in its A record, that IP version 4 or quad A, and it's not gonna be there. So now it's got to send it to its resolver to go find out. But it could be that the request comes in and says, this person is requesting the IP address for the Microsoft Active Directory domain server to log into the network. And so it says, oh, okay, you have a service locator request. And so it will give you, then it'll look in that SRV file, and it will give you the IP address of the Active Directory domain primary domain controller, and then you'll make a connection and log in. So these different files help it resolve whatever request you're giving it. Does that help?
Yeah, it does. I got a pretty good understanding. I'm trying to lock it down because you don't oftentimes go deeper than just that, first couple of IP levels. And then you realize that there's, like in this process, 4 or 5 possible with the root, then the DNS, and so forth. If any of those first 2 have it in their resolver cache, then you've got part of a problem solved, but it still has to kind of go through a protocol. And so I'm just locking it down.
Okay. So let's, for a minute here, let's jump back and talk about this cache, okay? And if I have a cache right here, okay, and I do IP config space display DNS, okay? This is my resolver cache on my laptop, okay? It's got a couple things in here. Looks like I have resolved this IP address right here for Zoom. Okay, let me make it bigger for you so you can see some of these. So Zoom has resolved to an IP address for me. Looks like I've got an auto discover IP address that's in my cache for stmartin.edu right there. And I have a Lenovo laptop, so it looks like my management has an IP address for getting access to management tools at Lenovo. Okay, and let's see. I'm gonna go up here. Okay. Then I've got some other ones, Lenovo. Let me scroll up a little bit. So I've got some stmartin.edu IP addresses in my cache. Some other things here you can look through, roaming office apps. So this is, here's Novell, gone there. So here's mail. Here's my St. Martin's mail, mail2019.stmartin.edu. Okay. So let me go down the bottom, and I can do an ipconfig flush DNS. Okay. And now it says Windows IP configuration successfully flushed the DNS resolver cache. Now, if I go to ipconfig display DNS, okay, one popped back up in there. But if I'm fast enough, flush DNS, and I do a quick display DNS, okay, there's nothing there. You see there's nothing there. And they're going to start popping back in as it goes out to the internet, okay, and resolves. And then it's going to put it in my cache. Okay, there's nothing there. All right. So now I am going to go to Amazon. Okay. Amazon.com. Okay, I went to Amazon. Okay, I'm going to jump back to my, and I am going to do an up there arrow, and I'm going to say display DNS. Okay, here we go. Remember, there was nothing in my cache 10 seconds ago. All right. Still going, still going. All of this, by going to this one website, was dumped into my cache. Okay, so it's dumped into memory. And because when you take a look at this, Amazon has dozens and dozens of things that they are selling. You've got Prime Video, you've got pharmacy products, you've got books, you've got a whole bunch of other stuff. It's not just based on one site, it's clicking on stuff to jump to a whole bunch of different things, right? Okay, so bestsellers or whatever, you know, you've got all this stuff there. Now, when you go back and you look at this, what did it put in there? Well, it put in, here's this for media.amazon.com. Look at the time to live. It was only 23 seconds. Okay, and so that's pretty fast. I mean, that's gonna age out very fast. I go up little ways. Here's, oh, that's interesting, pill pack. So they must do pharmacy stuff. That still has 31 seconds. This stuff is already aged out because I've been talking. It's already out of my cache. We got aboutamazon.com. It's got a whole bunch of stuff, blogs and CloudFront and a whole bunch of things that they're partnering with to jump. Ignite.amazon.com. Here's a bunch of IP addresses. Each of these, time to live, 165 seconds. It's counting down from 165. Okay, IMDb, Video Weaver. You got a whole bunch of things for. These are all different things that are components of this website. That it took all these things and dumped it into my cache. Why would they only give it a time to live of 35 seconds right here? Like this one. Why would they give it a time to live of 35 seconds?
Is it only activated when it's a rollover? Let's say that you don't click on it, but you roll over it, and so you may activate a portion of that Amazon layout, like an advertisement, or you're looking at something like that drop down, and if you fail to click anything on the drop down, that would be an unnecessary vector that you don't need. So it may just kill itself and wait for the next time you mouse click on.
Yeah. So I'm going to go into Amazon, and in a matter of probably 10 or 15 seconds, I'm going to find what I want, and I'm going to click on it. If I want to go to my Amazon Prime, or if I want to go to my recent orders or look at my account or something, very quickly, I'm going to go to what I need, find it, and I'm going to do a search or something. So all this crap they dumped into my cache because they want a fast user experience. They want you to be ready to go. It's dumped into my cache. If I click on any one of these links on this Amazon page, they've already resolved it for me. They've already stuck it in my cache, and they already have the IP address ready to jump to the IP address the second I click on it. You see, they've preempted my my DNS resolution to resolve these names, IP addresses. They put it all in here in expectation that I'm going to click on one of these things, and then I'm going to go to it. And if it's not one of these other things, okay, well, I don't know, several dozen, they're just going to age out in 30 seconds, and my cache is going to dump out, and it doesn't need to sit in there for a long time. It's pointless because I don't need it in my cache. I'm not going to click on it. I got to the thing I wanted to go to, and it jumped to it very quickly because it already had resolved the IP address. So I'm good. And so it just dumps, it just ages out of my cache. So now if I get down to the bottom and I do display DNS, okay, that's it. Most of that stuff is already aged out. It's aged out of my cache because it wasn't needed. I didn't click on it, and it's now out of my cache again. It's out of memory. All right. So that gives you a little idea there of that DNS cache. And does anyone know what the default DNS cache time to live, the TTL time to live is for a cached record?
$128,
128 seconds.
isn't it?
This is my old company, Novell. When they send this to you and it gets put into your cache, the sender determines how long it should be in your cache. Okay, so Novell is now part of Micro Focus, but display DNS. I think it's at the beginning here. Does it come up? It's got some more stuff. Where's DNS? By default, it is 24 hours. But that is the default, and nobody uses that default. But here's Novell, okay? And they have put in a time to live of 20,335 seconds. So 20,335 seconds divided by 60 seconds in a minute, 338 minutes divided by 60 minutes in an hour. That's 5.64 hours that this is going to sit in my cache until it ages out and gets dumped out of memory. Now the default is 80,000 whatever seconds. It winds up being 24 hours. Okay, and but you determine as the website that you go to how long you want this to sit in somebody's cache. It doesn't have to be the default. You determine that. Times 60 seconds. It's 86,400 seconds is 24 hours. So by default, if they kept the default and you see a cache here, it's 86,400 seconds. But you see that all those advertisements for different products and services on Amazon were in the 100 seconds, you know, a minute and a half to even down like 30 seconds, 15 seconds, right? If you don't click on it immediately, it just ages out, but it's just giving it a head start. So it's quickly able to go right to that additional sub website. Could be a sub website, it could be a separate or back end site or whatever. Right?
Mark, would you like to separate the idea of like a customer experience TTL versus obviously TTLs for kinds of software interactions, or for example, you're on FileZilla and you're loading a file. It's timeouts and certain things that you use with your software sets will really be much, much smaller compared to any of the customer experience or best practice, research that people enjoy when they go to a particular website.
Well, I think we talked about edge networks, right? And content delivery networks a little bit, and how you've got a website. Instead of going to a central website, because that's slower, Google's and Facebook's and others who need a super fast, or Amazon can have an edge, a content delivery network where they have this proxy server or a content delivery server like Amazon right at the edge of the your internet service provider, like that last mile from Comcast. They've got a server right there that you'll hit, and so it's very fast response time. And then when you throw in all those cache, those resolver cache, anything you click on that website is going to immediately jump to that website because there's no lookup at that point. You've already given everything I need, or what they think you might need. And so it immediately can jump to that sub page. And so it's very fast. All this is about making it a better user experience for you. Is that what you're meaning, Jonathan?
Yeah, I know a lot of people like you get the technical side of it, like, or someone like in Peter's position where you notice that something is slowing down or your servers are getting hit over and over for a certain type of request. These time to live features, if they're mishandled, can have an effect on your traffic, and it would be different depending on whether you're selling, 10,000 items or whether you're simply trying to ping, a couple machines to see if you can hit their front screens. So. Yeah, we're good.
Hey Mark, Peter just dropped the link for it. It says the old common TTL value is 86,400 seconds, which is 24 hours, but newer DNS method is extremely low, and I dropped a link for it. And it depends on the operation system, whatnot. Linux is usually 255, and Windows is 180, 128.
Oh, excellent. Thank you. Appreciate that, Peter. Anything else you want to add, Peter?
No, that was it. Gary had some questions on the chat, so I was answering them for him.
Cool. Okay, so let's jump to some slides. Does everyone understand this? Okay, and then this would be the complete solution to get an IP address to go to Amazon.com, okay? But if Amazon is still in your resolver cache and you type www.amazon.com and it hasn't timed out with a TTL, it doesn't need to go anywhere. It's in the cache. It's got the IP address. It's going to go there. Okay. If it's aged out, but it's still in the resolver cache at the DNS, your DNS level, then it'll go to the DNS server and the DNS with the resolver cache will say, here you go. Here's 52.13.1.7, and it'll give it to you there. If neither the resolver cache of your laptop or the DNS server that you're pointing to have that IP address in their resolver cache, then it will do those 3 iterations of a recursive search to go out to the internet, re-find it, grab it, and put it back in the cache, and then give it to you and put it back in your cache. And so this happens all the time, every day, every site we go to, this is what's happening.
Mark, do we know how many root servers there actually are out there? I know that you talked about those Amazon servers being multiple thousands. Is there a limited number of main root servers that we get to, at least on the US side of the fence?
Yes. There's a specific set, and they are hosted by specific, sometimes companies, and other times they are, let's see, root.
I know one of my first stumbling blocks, a long time ago was learning that a physicality, again, it's not just one big, computer. You got a company that's got, locations all over the world. They can literally make a domain stretch across thousands of machines and sources. So, but when it comes to the actual root server or the actual directing on the large scale, I didn't know if there was a new list. I don't know if it was like now up to between, 13 and 20 servers or something.
According to the IANA, it's 13.
Yeah, but that is 13 actual companies or things. So if you go to rootservers.org right here, and we can throw that in the chat here. So there are 13, it breaks it out into the rootservers.org, breaks it out into across the world. And you'll notice that their root servers are A through M, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so root servers are the A servers. If you look down here, can you see this? Is the operator is VeriSign Inc. You see the operator there? And then the sites, this is root-servers.org, The sites are 16, Amsterdam, Miami, New York, Paris, Ashburn, Atlanta, Chicago, Frankfurt, Hong Kong, London, Los Angeles, Seattle, Tokyo. These are the locations for these root servers, okay? This is the IP address in IP version 4, IP version 6. I think this is autonomous system number. But if I click on root servers B, so this is 13 groupings. There was actually just 13 at one point. But now this one is from Information Sciences Institute. It has 6 servers that they maintain. The C group is Cogent Communications. There's 11 sites for those root servers. D is University of Maryland. There's 149 sites. E is NASA Ames Research Center. There's 254 locations. Internet Systems Consortium, Inc. So this organization has 247 locations. G is Defense Information Systems Agency. Oh, DISA, right? Okay. And then H, U.S. Army Research Lab. NetNode, VeriSign, RIPE, NCC, ICANN, and the WIDE project. So these are the 13 groupings by different community programs, government organizations, or actual companies that are running these root servers that provide the initial requests when we do a recursive search and jump to the top level domain. And so in these regions, you can click in these regions even, and it will take you to, like if you go to here, and then you go to Seattle, and then you go to right here, here. And if I click on any one of these, here's the NASA Ames. The ones you guys are hitting either is this one, NASA Ames, or this one, Internet Systems Consortium, this VeriSign, this one, CTAC ICANN, and University of Maryland. So these are the ones in this location in the Seattle area here. So you can see when you zoom it in, you can get a little bigger, but these are locations, these are the servers that are up here locally that we would probably hit doing our own resolution. Again, top level, root servers. Then you would go to top level domain, and then you would go to the name server for wherever you're headed to get the IP address. So root-servers.org. Okay. Does that help?
Very much so. Coming from a telecom background, you got to separate telecom signaling from the way the larger internet works, and that pretty well did the trick right there. So you're good.
Okay. Okay, so let me minimize this then. My server's struggling, or my laptop's struggling here. Okay, we're running out of time, but I want to show a few more things on some slides. Okay, we talked about the resolver cache, we talked about a recursive search, we talked about the root servers and who owns those and how those are run. We talked a little bit about the files. Okay. What is this? Okay. Okay, I want to share this screen. Share screen. Okay, here is what happens when DNS gets thwarted, okay? In this, I'll put this link in to the chat. Okay, so you've got that in chat. It's the Wikipedia to an article about Dyn. It's a company. It's now been acquired by Oracle. Okay, but this company, so if you look it up and you can read it online, this is a little bit too small for you to read maybe, but you can, let me zoom in, I guess. Okay, in 2016, Dyn, which is a commercial DNS resolver, they do different things, but one of the things they do is commercial DNS services. They were attacked by a distributed denial of service attack. So many times we hear about a denial of service or a distributed denial of service where people will flood connections to a website, an individual website, and it overwhelms it and it shuts it down, right? But in this case, they overwhelmed a DNS server by sending DNS requests and so forth to this. Look what they used. They were able to get onto internet-connected things such as printers, cameras, residential gateways, and baby monitors. They used the Mirai malware to upload that to these Linux devices, and then they were able to remotely launch this distributed denial of service by a bunch of internet-connected devices by people totally unaware that they had taken part in this because they had left their default passwords on these devices. So they trolled the internet, they scanned it, and anytime they found something with the Linux operating system, they tried to log in with the default username or admin password, username and password for all these types of devices, DVRs and printers, cameras, wireless access points, and then they would throw on the Mirai malware, and then they had upwards of 300,000 devices that they launched against Dyn. So Dyn its job was to service all of these services, and it was primarily the East Coast, but for the matter of a whole day almost, several good chunks of the day, they had hundreds of thousands of devices sending DNS requests that overwhelmed Dyn, and the affected services was effectively everything you see on this list: Airbnb, CNN, Comcast, GitHub, Etsy, HBO, Mashable, Netflix, New York Times. You know, take your pick. These are big websites and big companies, and so by shutting this down, and if this was your DNS server, guess what? You never got an IP address response, so you never got to go to your final destination because you never was able to get the IP address. So it effectively shut down all of these websites. Even though they were still running, you couldn't resolve the name to an IP address when you typed it in your browser, so you couldn't go there. That's actually pretty smart. Instead of just shutting down one website, they shut down a couple dozen websites, right? So that is what happens when DNS doesn't work. You can't get to your resources, and in this case, this is a good example of Dyn. When it shut down, all these websites were affected, and people couldn't use these for several hours at a time during that day, and then they finally got it resolved. Obviously, they had to go in and block these IP address ranges and groups to the point where they were blocking that traffic. Okay, but that's a good example of what can happen. So when you create your when you put in this information in your server or in your laptop, or when you are given information that from DHCP, you can be given both a primary and a secondary IP for DNS. So if you could have had more than one DNS server, and it wasn't just Dyn, but you had Google 8.8.8.8 or something else, or some local DNS server, or Comcast, or I don't know, whatever, then it would try those DNS servers, those IP addresses of the DNS servers in order of use, you see in the right, with your settings in Windows. And by configuring those settings, then you could, then it would slow it down because it would error. I think it would error. Is that right, Peter? If it got to the first one, that was Dyn, and it connected, but it never resolved, would it ever drop that and try the next one in line, or would it just stay there and never resolve?
I have a feeling it would just not resolve, because it would, get a response from that server, but it wouldn't actually get the information.
Yeah, that's what I'm thinking too. If it didn't get a response from Dyn, it was completely overwhelmed, and so the connection never established with Dyn because of this denial of service, distributed denial of service, and it moved to the second, it would go to another DNS, it would resolve, and then they would be able to go to that whatever web site they wanted to go to.
Yeah.
So anyway, I think this is a fascinating that this is what can happen. And so DNS does one thing. It just resolves a name to an IP address, but that one thing is super critical to the function of the internet, to the World Wide Web, to finding mail servers, to logging in with Active Directory, to finding whatever resources you need on your network. If you type in a server name by name, it's got to resolve to the IP. So this is DNS is a big component of networking. Any final questions? We're about out of time here.
I have a question.
Yeah.
Are we gonna have a quiz this Thursday?
No, we're gonna push it back.
Also, is the lab going to be pushed back too, or is it going to be due tonight or tomorrow? Our first one.
What are we referring to?
Our first lab. It was assigned to be due, I think, tomorrow night.
The packet tracer exercise?
No, it's IP subnetting questions.
Oh yeah, that's pushed back. We haven't gotten there yet. I'll push those back. I'll get on Moodle and update all that.
Yeah, I really would
Alright,
appreciate it,
sweet.
like if this stuff was clearer on Moodle.
Yeah, I'll get those squared away out so they're in order, and when those due dates are more accurate, that way we can better plan for that, because we haven't even hit IP version 4 yet, talking about it yet. Yeah, thank you, appreciate that. Okay. Any other questions? Okay. Great. So hopefully that was helpful, and I'll update Moodle, and then we will see you again Thursday. I should be able to get on. I'm down in California this week, and but I'll coordinate with Peter for what we're going to teach, and if I can't get on, Peter can drive Thursday's discussion. I need to go down and help my sister. She's just not doing well. She's just all by herself. So anyway, so I will be back next week, but we'll update Moodle and have that there, and then hopefully I'm on, and we will see you Thursday.
Fantastic, Mark. Thank you.